Uh, Welcome everyone. Thanks for coming for the next topic within this track related to performance testing for web scale capable applications. First of all, let me introduce myself. My name is Izzet Mustafaiev. I'm working for EPAM. I'm a happy father. I have a son. He's about 1 year old. My primary language is programming language is Java. I'm also hands coding with Groovy, a bit of Ruby, and recently started to explore for myself functional programming with Erlang and Elixir. I'm also passionate about agile approaches, clean code, and DevOps movements, ideas, etc. So that's it about me. Let's continue to our agenda for current session. Hello? Can you hear me? Yeah. So first of all, I would like to answer why we need performance testing. Because like most of us are developers and usually we do not care too much about performance testing. Then there will be some reference to what is actually performance testing. Then there will be the most huge part of this presentation related to theory of performance testing and how to actually do a performance testing. Then there will be some overview of existing performance tools for developers to actually do a performance testing by themselves. There will be a short demo during which I will demonstrate how to pretty easy and fast to make a huge load for your application. Of course, there will be a summary, the most key points that you need to take after my talk, some references, and of course, you will have a chance to ask me questions. Okay, let's start. First of all, why should we care about performance testing? Most of us are developers, right? Please raise your hand. Who is developer here? Okay, thank you. In most projects, we are caring about performance somewhere in the beginning, at the end, right? When we think that almost everything finished, right? Everything will be done, and we will have enough time to start actually to do performance testing. But actually, it's not the right approach, and I will tell you why we need to pay more attention to performance testing. First of all, there is, sorry, громче? Okay. First of all, there are some numbers, and numbers cannot lie. According to some statistics, the page load above 3 seconds actually will lead to abandon your site by your customers. Because if your site's pages load in more than 3 seconds, about 43% of your customers will never return to you again. So it's almost half of them, right? So it's pretty huge number, so we need to care about this. If those numbers are not really motivators for you, so I have another ones, and this is language of money. Amazon actually calculated that if their page load will increase for just 1 second, they will lose about $1.6 billion a year in sales. So it's pretty huge number, and if you compare it, for example, you know SpaceX, right? There is a Falcon 9 rocket, and actually to rent this rocket for one launch, it costs about $62 million. And for such amount of money, we can actually rent this rocket for 25 times. It's actually with 25 times could go to space. Pretty huge. Okay, now I believe you know why we need to care about performance testing. So now let's get understanding what is actually performance testing. Performance for end users is simply how application behaves on their actions. So when I click something, then I wait a response, and this time is actually performance for end users. Wikipedia says that performance testing is actually the process that helps you to determine how your application will behave under some particular load. Will it stable? Will it continue to serve your customers, etc.? That's it. Let's continue to next part of this talk related to key characteristics that we are looking during execution of performance tests. First of all, we are looking for availability. We are looking to determine the load before which our application is still available, because only available application is actually able to earn money for us. Unavailable application is just useless, so it's died, customers are not serving, etc. So availability is pretty important key characteristics that we are looking for during performance tests. Another key characteristic is called concurrency. And this is probably the least understood characteristic because there are actually 2 points of view of this term. From one point of view, we have a tool that is actually make a load to our application. And concurrency from tool point of view is actually the number of users that it generates during the load. And there is another point of view of application. And concurrency for your application is actually the number of users that are hitting or making a request to your application. And at given particular time, those numbers could be different. First one is pretty dependent on type of scenarios you are using to make a load for your application. And the second one is actually like from point of view of application and how it behaves under this load. For example, if we are talking about e-commerce, right, or some online shop, usually customers go search for some products, comparing them, and then add to cart, and then go to checkout. So this is actually not like a step-by-step process. There is, for example, customer finds the product, think about this, read descriptions, specifications, comparing several products, and then decide to add it to cart. So there is a sync time between this, and in this type of scenarios, concurrent users will be different, for example, from stateless application, where our aim is to make a load because we do not care about state. We're making requests again and again and again to determine how application will be behaving under these conditions. Another key characteristics that we are looking for during performance test execution is response time. We are, as a users, actually pretty care about this because we are impatient. We do not like to wait. And response time is actually the characteristics that demonstrates how application is user-friendly. It means that it responds quickly and does not force us to wait. And there is one more key characteristic called throughput. Throughput is actually the rate of events that occur to your application. And throughput and response time pretty dependent on each other because from one point of view, we would like to have the highest throughput as we can. Because in this case, our application will be capable to serve much more customers, right? But at the same time, with increasing of throughput, response time will be also increased. And this is not good because we do not want to wait. And during performance tests, we need to find this balance between high enough throughput and low enough response time so that our application will still be useful. Проблема с интернетом. Some internet-related problems. Let's use backup thing. Okay, response time, throughput. Okay, when we know what we are looking for during performance tests, let's continue to actually the decision when we need to start to performance testing and when we need to start care about performance of our application. First of all, I would like to pay attention to readiness. The fact that your application is ready, or at least some of your application is actually functional, and after this point of time, we can start performance testing in a healthy manner, because when your application is not ready, it means that you will continuously rewrite your performance testing scenarios and it won't be enjoyable. So we need to wait a bit and then start to do it. Also, please make sure that you reserve enough time for performance testing, because usually we delay it to the latest moment and then it's already late. In order to avoid this, think about the reservation of time to do this. Think about that you need to prepare some environments that will be exactly the same as production. You need actually to provision some load machines that will generate the load, and if we are talking about web scale applications, so it means we have a distributed environment, so we need to prepare for this. And also think about data that needs to be generated and to write for scenarios, and the most important one is to think about the times that will be required to fix all related bugs that you will find during performance tests. One more thing is to do it continuously. We have a state from Donald Knuth that says that premature optimization is root of all evil. From one point of view, it's definitely true, but there is another point. For example, we are in agile world, right? We are implementing our software in agile manner, in iterative manner, and from the very beginning, we are striving to make something functional. So when it's functional, it means that it won't be changed too much. And it means that we can start to do it, to do performance testing of our application, at least if this features that was implemented is okay to be covered with performance tests. When we do it earlier, it means that we will get much more quicker feedback. And if feedback, for example, there are some performance degradations, so to fix this will be cheaper and less painful. Okay, now let's go to the next chapter that will be answering some question related to actually what to choose to cover with performance tests. Sorry. But before to deep dive into this, let's overview what type of performance tests actually exist. Usually, each application designed for some. I do not have the steps here. Okay. Usually, each application designed for some normal operation. This is here. And there is a type of test that will help us to determine the max design operation capacity. It's called stress test. Its purpose to determine the point after which our application will continuously throw in errors or will become unavailable or will just fail. So this is a point when our application becomes useless. And stress test will help us to determine this. There is another type of test, the aim of which is to determine behavior of our application under some patterns of usage. Because, for example, if it's online shop, it means that during Black Fridays, it will be overused. Or if it's some bank operation software, it means that it will be overused during working days and will be idle on the weekends or in the night. So we need to determine how our application will behave during these peak loads. And for this, we have a peak load test that are running for some period of time, and the load is actually higher than normal operation, but less than max design operation capacity. Another type of tests that will help us to determine some memory leaks or like issues that related to like running of our application for long period of times. It's called soak test. It's this type of test, during which we're actually executing them for some long period of time, for example, for 24 hours or during weekends. And this will allow us to determine these memory leaks. And this type of test, the load is not so high. It's so somewhere between peak load and normal operation capacity. And there is one more type of test called spike test. And the aim of which is to determine whether our application will survive under some huge load, but for short period of time. So it means that we are making load much more than max design capacity, but for short period of time, so our application will start to throw errors, but when load goes away, our application should recover. So this type of test will help us to determine like our recoverability capabilities of our application. Okay, as for what to cover with performance tests, first of all, we need to come up with consensus. Because usually on projects we have customers, we have developers, QAs, performance analysts, some stakeholders, etc. And each of those groups have different opinions on what is actually performance tests and what we need to cover and what results we actually should get from this process. So we need to come up with consensus, document what is inputs and outputs of our performance tests, what scenarios we need to create, what requests, responses we're expecting, etc. And what actually targets should be covered. And as for targets, we need to choose the most valuable for our business or for our application, because to cover everything, it's pretty expensive. So we need to be pragmatic in this. The next point is related to scenarios, because scenarios is actually like the main execution part of performance tests, and depending on how we create those scenarios is actually will demonstrate how efficiently we will do performance tests. And scenarios should be related to our business and for most critical part of our application to cover the critical business parts. Okay, now we know like some preparation, what to test, when to test, what we are looking for during performance tests. Now let's go to the next chapter related to how to actually execute performance tests. First of all, we should to think about volume of data we are using during performance tests, because it doesn't matter to run the load on some like 1,000 records, like for example for search, when we expect to have in production millions of records. So in this case, our performance test results will be irrelevant. So we do not able to trust them. Also, nowadays mobile clients are becoming the most critical part of users of modern applications, and mobile networks are quite heterogeneous because we do not have Wi-Fi everywhere. Finally, we get 3G, but we still do not have LTE, so networks are pretty different. And slow clients make our application slower. In order to determine how our application will behave in this situation, we need to emulate some slow networks to get some understanding how application will behave under such conditions. Also, along with execution of performance tests, we need to care about monitoring. and monitoring not just of our application, whether infrastructure that was provisioned for our application is capable to handle this load. But we need to monitor boxes that are actually used to make a load to our application. Because if, for example, machine with our load injector will be overloaded, it means that our performance test results will be corrupted, so we cannot trust such performance results. So we need to monitor not just our application, but our software that make a load as well. Also, one more thing related to execution of performance tests is to think above the limits. There is a fact that, for example, in 2014, during 4 days weekend of Black Friday in US, they were spent $50.9 billion, just 4 days. And most of those money was spent online. And this number is growing. It means that there is a huge, the demand of online applications is higher and it's increasing. And we need to think about how our application will behave under such conditions. What will be after 6 or 12 months with it? Will it handle this load, or maybe we do not expect that it will be much more popular? So think about this during execution of performance tests as well. And of course, we need to carefully choose tools to execute performance tests, because tool can make impact on results of our performance testing process. For example, G-meter actually fails with out-of-memory errors under some load. So we cannot trust such tools that actually fails by itself when it's not capable to make a load. We need to choose right ones that are capable to achieve the expected amount of concurrent users and etc. Okay, now we know how to execute performance tests, what to think during execution. Now let's move to the next logical part related to collecting the results. What actually we are collecting during after performance tests were processed. First of all, it's measurements, because right measurements can demonstrate us the most relevant information how our application behaves under the load. And for measurements, we of distributed applications that are capable to handle web scale load, we cannot trust absolute values, because, for example, average or mean or max values are not relevant anymore. Because, for example, if we have 10 requests and most of them were under 200 milliseconds and some of them above 1000 milliseconds, and average will not demonstrate us the actual value of performance of our application. So we need to use percentiles. Percentiles, actually, for example, 95 percentile of 200 milliseconds demonstrates to us that our application, 95% of requests is capable to serve under this 200 milliseconds time frame. So it's most relevant to us. Another point is distributed environments that are used to run our application and to run the load. And distributed nature all become much more complex. Because our application is distributed, we need to collect logs, we need to collect metrics in some single place in order to analyze and to refine some issues that are appearing during performance tests. And to do this, there are dedicated tools. For example, we can utilize elk stack to gather logs and to make some queries to analyze how our application behaves during the huge load. And that's probably it about this theoretical part. And next, we are moving to overview of existing tools that could be used by developers to make a performance test. Actually, there are many different tools. The most probably popular ones are like dedicated for performance analysts, for probably QAs, etc. But we as developers do not care about UIs, right? We are coders, we would like to program something. And I would like to introduce you several tools that are suitable for us as developers. For example, Yago, it was written by Twitter. It's actually not a framework or tool, it's just a library that provides some API to write performance tests. For example, if you need exactly 1,000 requests per second, this tool is capable to make this. It won't have a mercy for your application, so if it dies, it will, or if it slows down, it will continue to make such amount of requests according to your request from it. There is another tool called tsang. Tsang is written in Erlang, and Erlang means distributed, so it's actually good to make a distributed load for your distributed application, but there is some nuances with this tool. It uses XML to describe performance test scenarios, and it does not provide good measurements. But it still could be used to make a huge load. Another tools are written in Python. One called is Logcast. It provides UI for performance test creation. It is capable to make a load in distributed fashion, so it can use several machines to do this. Another tool called Zobkayo. It was written by LinkedIn, also in Python, and the main advantage of it is actually you can write performance tests the same ways as you do for unit tests. So those are great tools, but there is probably the greatest one it's called Gatling. Gatling is probably more relevant to our conference because it's written for JVM, it's written in Scala. It follows non-blocking I/O and asynchronous reactive approach. It utilizes Eka and Netty under the hood. It also provides pretty nice DSL, and actually this DSL is pretty expressive, and even not developers could understand it. I will demonstrate it a bit later. For lazy guys, it provides some UI for recording scenarios of usage of your application. Also, it provides reports with what is important, right measurements. It's also capable to make a distributed load and provide some real-time monitoring of metrics that it collects during performance tests. So this is demo time. Let's take a look what we have. So first of all, let me show you architecture of this demo. So probably you can see it. Okay, we have a small service called patient service that provides some pretty simple API. Here we have a performance analyst that will use Gatling to make a load for our application. Gatling will feed performance test metrics to InfluxDB, and performance analyst will use Grafana to analyze charts that will be constructed by data from InfluxDB. So pretty simple. Then let me start a demo, and then I will demonstrate the code of this application of performance scenario. It's slow. I don't know why. Okay, looks like working. So I have a virtual machine where my application will run. Okay, let's start application, and here you have a logs, and here you can see I have two containers, Docker containers. One is with Grafana and one is with InfluxDB. And now let me make some load. Okay. C scale Gatling 5. So I will schedule 5 containers with Gatling inside, and they will run my performance test scenario against this application. While we're making the load, let me demonstrate performance test scenario. Actually, here is Grafana console, and as you can see, there is no any information yet. So here is a performance scenario. It's actually a regular Scala file where we have 2 scenarios. They're using a feed from pretty simple CSV file. Here we go. So we have simple CSV file with a first line is a header that defines the name of columns within this CSV file, and those values will be used during our performance test scenario. Then we are defining 2 scenarios. One is for loading of patients from our application. We will use an HTTP stack get method. So we will call this endpoint, and this value will be picked from this CSV file that I showed just several moments ago. Along with just making a request, we can check responses from our application. For example, here we have a check that requests are succeeded, and here we have a check that response contains some particular values. In our case, it's ID of patients that we are loading. Another scenario is related to creation of these patients. We also use feed to get values from to create new patients. We use HTTP stack. We'll make a post HTTP method calls to our application for given endpoint again with parameterized values, and here is request body in JSON format to create patients. And again, we are checking the response. Here's a think time. So it will actually wait for 2 seconds between each call. Here we have a configuration of HTTP stack. So we defining the base URL of our application, some common HTTP headers. And then actually the most interesting part is actually setting up of load. So here we have like scheduling of loading of patients with ramp up users over 2 minutes up to 50. and then the peak load will be 100 concurrent users over 20 seconds. And for creation, there is a bit different scenario. We have ramp up users up to 10 over 2 minutes, and constant users per second will be 5 during 50 seconds. So as you can see, it's pretty expressive, and you do not need to know Scala or Java. You can just read it as a plain English. And there will be max duration of this test is for 10 minutes, and defining the usage of HTTP stack. So let's check what's here. So scenario is running, but I do not see results. Here we go. We have some results. So as you can see, there is a load to our application, and runtime we can oversee how it behaves. We can use create additional queries, more detailed ones, but here we have, for example, requests per second, 95 and 99 percentile, max response time, mean response time. So all is aggregated, collected from those 5 instances of our load injectors into one single place, and we can analyze it. Along with this, we're also capable to aggregate logs from our application, and that will be helpful to resolve some performance-related issues. Okay, that's probably it about demo. Let's go further, and actually there are takeaways that the most key points that you need to remember after my presentation. So do performance testing continuously, because only in this way you will have quicker feedback and you will have cheaper conditions to fix performance-related issues. Do performance testing only with right amount of data, because only in such conditions we can trust our performance test results. Monitor your infrastructure. It means that not just your application, but your performance loaders as well, because only in such conditions you can trust your performance test results. Use the right measurements. Do not rely on averages or mean max values. Use percentiles, because it's most relevant information for you related to behavior of your application under the load. Choose right tool that makes less impact on results of your performance testing, because otherwise you also cannot trust your results. And automate deployment and testing processes, because only in these ways it will be much more enjoyable. So it's not okay to execute performance tests manually, collect results manually, analyze them manually. So everything should be automated. In this way, it's much more enjoyable to do this. There are some references, so books, links to use tools, and source code, the last link of this demo, so you can actually clone this repository and run everything on your local machine. And this time for questions, we have about 4 minutes, I believe. Yep.
Any way to work? Do Gatling have any way to work with sockets, with custom protocols based on sockets on RMI? So not just REST, but something more hard, something more custom. And the second question, here we had one request, and we took statistic by one request. But if I want to work with sequences of requests, with some big scenarios, variable scenarios that based on when the next request is based on the answer on previous request.
Okay, as for first question, Gatling has support of many different protocols, WebSockets for sure, JMS, and there are a bit more, I just do not remember right now. Not sure about RMI. As for scenarios that will use like results from previous tests, right? It's like in your hands pure language. You can use whatever you want. So you can parse results in order to use responses. As you can see, he is. So actually, this is a response from the REST call, right? And here I'm like using JSON pass, searching for particular values from the response. So you can use it. Okay, actually, I forgot to.
Can I add some custom protocol to Gatling? Not just from library. Yes,
Yeah.
okay.
This API, you can do whatever you want. As I said, it's like performance tool for programmers. Let me demonstrate one more thing. Today. It's a result of like this performance test scenario. So as you can see, there are like pretty charts with lots of information like okay responses, percentiles, different percentiles, some details, etc. So pretty detailed. Okay, next question.
How did you collect your data into Grafana service?
Gitling has built-in functionality to feed metrics to Grafana or to InfluxDB, and then Grafana is able to make a query to InfluxDB to draw these charts. So according to this diagram, so you can see Gatling feeds InfluxDB with metrics it collects, and then Grafana makes a request to InfluxDB and draws these charts. Okay, do you have time for questions? Huh? Okay, sure. There are some questions here. Wait a second.
Scala. We can use Java for writing suites, or we should use only Scala?
Actually, it's not Scala, it's a DSL to like describe scenario. There is like interoperability between Java and Scala, right? But I'm not sure about usage of Java to describe performance scenarios for Gatling. It's easier to use this DSL because, as you can see, it's pretty expressive. You read it and you understand what is under the hood. And this is like the most advantages of this tool because everything is like could be described with this powerful DSL. Okay.
Maybe you say about some ideas that support context help for understanding what we can do. For example, after dot.
Well, this like regular IntelliJ idea, and you can use code hinting, etc. And REST API, pretty good documentation of Gatling of its API, so it's pretty useful. Okay, that's it. Okay, thank you for your question. Enjoy the rest of the conference. Bye.
It's like it's a valid proposition to use of storage.